we're going to start out with an example here to kind of understand why we would do what we're going to do. But if you have a calculator, it could kind of do all of this for us. But it's kind of a cool idea. You really already know how to do today's lesson. It's just got a small little tweak to it. Okay, so not a whole lot going on new. So if I were to ask you a simple question, and I want to know what the square root of 64 is, hopefully you would quickly tell me my answer is 8. Good. But what happens if I want to know what the square root of 65 is? Well, I know it's slightly bigger than 8, but I don't know its value. So what we're going to use is we're actually going to use our tangent line to help us estimate that value. So let's take a look at what's happening here. We're technically looking at a square root of x function, and if we were to graph that, it looks something like this. Well, right here at 64, my y value is 8. I am going to create the tangent line at that point, and then I'm going to base my answer for the square root of 65 off of my tangent line, because it's easier to interpret a line than it is a square root. So, like I said, I'm going to write the equation of my tangent line here. If you remember, we write lines y minus y1 equals m times x minus x1. Then to figure it out, we just isolate the y, and our line looks like this. Well, for linearization, or our linear approximation, I'm going to write it and make it look fancy like I'm in calculus. And it looks like this. F prime of A means slope at A, and F of A means y at A. So again, it just looks fancy. It's the same thing we've been doing. It's just in calculus vocab. Okay, so what I need to write the equation of my line is I need a point and I need a slope. Well, we already have the point we're basing our tangent line off of. X is 64 and y is 8. So I need to find the slope at that point. So I'm going to take the derivative of my function here. So I'm going to take the derivative of the square root of x, which is 1 over 2 root x. And I'm going to plug in my x value. So 1 over 2 times the square root of 64, that's 1 over 2 times 8, so that's 1 over 16. So now I know my slope is 1 over 16. So I'm now able to fill in my equation here. So I'm going to plug in L of x equals f prime of a, that's my slope. That's 1 over 16, x minus a. A is my x, which is 64, plus f of a, which is my y value of 8. All I did was write the equation of my tangent line. That's it. And now I'm going to use my line to estimate the value of the square root of 65. So here, I'm going to plug in my 65. So that's 1 over 16, 65 minus 64 plus 8. 65 minus 64 is 1, times 1/16 is 1/16 plus 8 is 8 and 1/16. Well, if we're curious here, I'm going to ask my calculator, what is the square root of 65? And it is telling me 8.0623. And if I take my 8/16, this guy is 8.0625. So that's a pretty solid estimation. That's pretty cool if you ask me. And from here, we can tell that all of our estimations are going to be over because our tangent lines are all above our curve. And we'll talk a little bit more about that in the future. All right, so that is linearization. All you're doing is writing the equation of a tangent line, and you're going to use that to estimate another point. So let's look at a quick example before we say our goodbyes. Let's say all I'm given is f of negative 4 equals 3, f prime of negative 4 is 2, and I want to know what the value for negative 3.6 is. So here it looks like they've been given less information, but we've been given everything we need. We have our point and we have our slope. So I'm going to write my function. L of x equals slope, which is 2, x minus a, which is negative 4, so that becomes x plus 4, plus my f of a, which is my y value of 3. So they gave me the information. They gave me my slope, my x, and my y value. So I plug that into my linear function, and now I'm just going to plug in that negative 3.6. So L of negative 3.6 equals 2 times negative 3.6 plus 4 plus 3. Negative 3.6 plus 4, that's going to give me 0.4. 2 times 0.4 is 0.8 plus 3. So I get 3.8, which is pretty close to where my negative 4 is, which tells me we're right around in the same ballpark. Seems doable. Okay, good luck with linearization. If you have any questions, let me know.